Appreciate the chance to give a 5-minute talk. Can't say a whole lot in 5 minutes, but what I hope to say today, we're a CRO. We provide bioanalytical services, small molecule, and also in vitro ADMET. And what I hope to leave with you today is a little bit of an idea of ways that we're doing things differently. There's a lot of us out there, and what we're trying to do is things a little bit more creative and to learn from it. So I'd make the argument in the last 10 years, we haven't really changed what we've done very much. From a bioanalytical perspective, it's very much not seeing the forest for the trees. We're very batch-centric, and we lose the opportunity to learn more broadly. There's a lot of compound dependency. We focus on standards and QCs, knowing that they're not necessarily relevant to study samples. We have these very expensive capital equipment mass specs, and we don't ask them to do very much. Matrix effects. I'd make this statement that they're little understood and too often invoked. And there's a little bit of what I call the ostrich scenario. And sometimes, people don't, they're a little nervous about looking at data quality. So I don't think we've changed a lot in the last 10 years. And I think a way of doing that is to take a step back and look at what we do kind of from a manufacturing perspective. It's a process. You've heard at this meeting today about process engineering. But look at it as a sequential process and see what you can do to improve its reliability. Standardization is the key. A lot of what I'm talking about is discovery bioanalysis, where people want fit-for-purpose data really quickly. You don't have a lot of time to do optimization. So standardization is a key. Variables cost time. Variables cost money. Start simple, add complexity when you know you have to. Minimize single points of failure. Think about building in diagnostics into the assay. There's no reason you can't do that. If you have 2 days to turn something around, you don't have a lot of time for troubleshooting. And establish a common point of reference. And I'll show you an example of that. That's really helpful from a troubleshooting perspective. I'm going to just skip over this, but what we're trying to do is take the opportunities provided in discovery bioanalysis, where you can do things that you simply can't do when you're doing regulatory work. You can evaluate new technologies. Your risk tolerance is much higher. It's a great place to try things and learn from and then generalize elsewhere. And there's a lot of dogma out there, and I would challenge us all that we need to kind of look at that dogma. Don't assume it's true. So one way of doing this is, and it's a simple concept, but increase the experimental dimensions or the yield of your experiment. You can weave experiments within the experiment, and I'll give you examples that will give you more information, or if you run into a problem, will allow you to possibly troubleshoot it without repeating it. So there's a lot of ways to do that. Another thing is to focus on real study samples as measures of data quality. Too often, standards and QCs, they don't mean much. They're not really, they're surrogates is what they are. And really leverage the mass spec capability. So often, we have it look at analyte, IS, analyte, IS. Today's technology can do much, much more than that. So here's just kind of a simple example. We're calling this an injection standard. And simply, in a discovery setting, it's a straightforward protein precip. And what we do, a little bit different, is after we take off the supernatant, we add water to that contains another standard. That standard is in every assay we do. We call it an injection standard. In essence, what it is an intra-sample system suitability. And it gives you all kinds of benefits. A, you have a common thread across everything. It allows you to quickly troubleshoot chemistry issues from chromatography issues, from instrument issues. It allows you to detect autosampler misfunctions. It allows you to detect internal standard misspikes. There's a lot of things it can do, and it's easy to do. And it just costs you a little bit of mass spec time. And really quickly, other things that we're looking at is embedding in QC diluted samples a readback. You think you diluted a sample 10-to-1. There's ways of embedding in that a marker where you get a real sample readback of what that dilution factor is. Same thing with extraction aliquot volumes and the like. So there's a lot of ways that we can weave things in to make it more diagnostic and more meaningful.